Hello and welcome everyone to our lecture where titled Proposed NOMA with Dual Transmission in Multi-Cell Network. In this lecture, I will be discussing the system model, the mathematical equations, and the mathematical equations behind the algorithm that is used in this multi-cell network. So, starting the lecture with the system model. In this system model, we have we have two multi cells. It is similar to the comp structure in the literature, coordinated multi-point communication. Um, in this system, uh, the user 1 and user 2 data streams are mathematically multiplied and mathematically superimposed with the precoder matrices. The basically the if you consider the single cell is operating similarly to the one explained in the previous lessons. So here we have multi cells. Similarly, at the same time, when the first cell is the base station one is transmitting the data from antenna one and antenna two. At the same time, there is a dual transmission, same as the base station one from the base station two, where user one and user two data is superimposed with another set of precoders, that is 3 M3A and M4A and M3B and M4B, and the data is transmitted from two separate antennas via dual transmission, and the dual transmission occurs simultaneously from the two antennas from the two base stations, sorry, with the help of four total antennas. And in this work, the signals of user 1 and user 2 are first superimposed or mathematically multiplied with the precoder matrices. After this superimposed data is transmitted to the receiver in two rounds. Each round of the base station occurs from a different active antenna, so that different channels are used in each transmission. The dual transmission occurs simultaneously from both the base stations, base station 1 and base station 2. To make it possible, we ought to devise and develop a specific kind of precoders that can concurrently provide protection against internal and external eavesdropping. By internal and external eavesdropping, I mean that an external eavesdropper can't hear the information and user one can't hear the sensitive information of user two that it wants to protect. Neither the user two will be hearing the sensitive information of user one. So this system will be providing security against internal eavesdropping as well. Adding on to it, two users with dual transmission from each base station add greater complexities to an eavesdropper than the single user channel based protection algorithm. Um, in every transmission node of the proposed algorithm, there is a separate intelligently devised precoder matrices that will be descripted only at the authorized receiver. So this system is provide is transmitting the signal via dual transmission simultaneously from two base stations. So it is employing the same concept as the single cell communication system, but this time we have two base stations with simultaneous transmission with same process as the single cell communication secure communication network as we described in the previous network. So I will just quickly explain the mathematical equations and the expressions behind this work. You can, for a more detailed study of this work, you can go through my paper, the journal paper on multi-cell secure communication using non-orthogonal signal superposition with dual transmission for IoT in 6G and beyond. This paper will be published in RS Open Journal. This is a preprint version of the paper, and this paper will be published hopefully in April 2021. So I will go through the mathematical expressions. So the transmitted data from antenna 1, antenna 2, antenna 3, and antenna 4, as this illustrated in the system model, are given as follows. The transmitted signal from antenna 1 is the data streams x1 and x2 are superimposed with the precoder matrices M1A, M2A, and then sent via dual transmission for base station 1 and similarly for base station 2. So the received signal at user 1 from base station 1 can be written as follows, where Y11 represents the received signal at user 1 from antenna 1. Receive signal Y12 represents the receive signal at user 1 from antenna 2. H represents the channel between antenna 1 and user 1. H12 represents the channel between antenna 2 and user 1. Z here is the noise. Similarly, the received signal at user 2 from base station user 1 from base station 2 can be written as follows, where Y13 represents the received signal at user 1 from uh, antenna 3 and Y14 represents the received signal at user 1 from antenna 4. And the equations can be written as follows. The combined receive signal at user 1 from base station 1 and base station 2 is the sum of receive signals from antenna 1, 2, 3, and 4. And by putting on the values, we can solve the equation as follows. Similarly, for the case of receive signal at user 2, we follow the same steps as we follow for the base for the receive signal at user 1. First, we calculate the receive signal at user 2 from base station 1 from the four antennas. Then the combined receive signal at user 2 from base station 1 and base station 2 is then calculated by adding on the signals from both base station 1 and base station 2, because base station 1 is employing dual transmission, base station 2 is also employing dual transmission, and these dual transmission occurs simultaneously, and the combined receive signal is the addition of all these terms. So after simplification, we get the following equation, which is pretty long. Similarly, for the case of receive signal at eavesdropper, we follow the same steps. It is to be noted that the first term is desired term for user 1. The x1 term is desired term while x2 term is not desired. For user 2, the x2 term is desired while x1 term is not desired for it. For the design of precoder matrices, we follow the same steps as we followed for the single user system. The first term of user 1 and the first term of user 2, the receive signal at user 2, is equated to 0, and the first term of receive signal at user 1 is equated with the identity matrix, and by solving these equations simultaneously, following the linear algebra, we considered the values of M3 and M3b as matrices X and Y. These matrices can be any value from the infinite number of matrices. These X and Y matrices can be any value of matrix from infinite value of matrix. For plotting the results on MATLAB, we considered it as one, or we can consider the matrix value as two, or any value from 0 to infinity. So the value after the simultaneous transmission of equation simultaneous solving equations 29 and 30, we get the values of m1a, m1b. And similarly, for the second set of precoders, we consider the second term of user to receive signal as identity matrix, and the first term of and the second term of user one receive signal as zero. And by considering M4A and M4B as matrices A and B that can be any value from 0 to infinity, we solve these equations 33 and 34 simultaneously, and we get the following set of decoder matrices for M2A and M2B. These are the intelligent precoder matrices that will be superimposed with the transmitted signals on base station 1 and base station 2 to provide us with the great results. So the significance of the proposed algorithms. I will talk about the significance of the proposed algorithms. It's that it can provide security against external eavesdropping. It can provide security against internal eavesdropping. It has less complex. It is limited processing. It has enhanced complexity for eavesdroppers. It provides security against the external eavesdropping because of the channel dependent precoders, and there is no leakage of information between the eavesdrop between the users even. And due to the diagonal channel matrices used in the algorithm, the inverse operation is very simple, and the precoder matrices can be designed by simple computation. Due to simple computation and dual transmission from two antennas on at both the base station, there is automatic interference cancellation. Um, Due to the specially designed precoder matrices, it can also support applications with limited processing, such as IoT-based applications. And the channel-based precoding matrices of the two users that are transmitted via a dual transmission from two antennas, it is more challenging to eavesdrop compared to the channel adaptive secure transmission based on single user. So these are the advantages and the significance of the proposed algorithm. I hope you have understood it very well. In the next slide, we will be just going through the simulation codes and the simulation results of both single cell and um, single and multi-cell network. So I hope you understood this lecture very well, and thanks for your patience. We'll see you in next lecture. Thanks for your time.